Okay, this is the lab for AP Stats. Where do I stand? Part 2. So this is going off of the first Where Do I Stand lab, the one that we ended Unit 1 with. And on here, we are given a dot plot representing the heights of 20 AP Stats students. Notice right next to the dot plot, it gives us the summary of data. That way we don't have to calculate too much here. Okay. So number 1 says describe the distribution. Remember, when we're describing distribution, we need to make sure that we describe S, O, C, V, and then context. Okay, remember S is our shape, O is the outliers, C is the center, so like the mean, and V is the variability, so the standard deviation. And then context is just making sure that we are phrasing our distribution in relation to what the problem is representing. So describe the distribution. So I would say that the shape of the distribution of heights is fairly symmetric and bimodal. There are outliers at 56 and 78 inches. The mean is 67.45 inches. And the standard deviation is 4.807 inches. So here we described the shape. So right here, the shape is fairly symmetric and bimodal. That's S. O is outliers, so the outliers at 56 and 78, and we can clearly see that on the dot plot. Same with symmetric and bimodal. It looks like the symmetry is right here around 68, and notice how it's very similar on both sides. That's why we said it's fairly symmetric. And then that bimodal is because we can see two significant bumps here. We see one here and then one here. Okay. And then let's see our center. Remember, our C is the same as mentioning the mean, and we said the mean is 67.45, which we find here on the table. And then V, our variability, is the same as mentioning our standard deviation, which again we labeled as 4.807, which is again on the table. The context is what we're talking about. So instead of just saying the shape of the distribution is fairly symmetric, we said the shape of the distribution of heights. Heights is our context because that is what our data is describing, the heights of 20 AP Stats students. Okay. Part 2, A says Ariana is 65 inches tall. What percent of heights are less than or equal to 65? So less than or equal to is the key here, meaning we are finding all the heights that are 65 and smaller. So 65 is right here. So we are counting up all of these dots. So there's 1, 2, 3, 4, 5. 5 dots. So that's 5 people who are 65 inches or taller, 65 inches or shorter. So we have 5 divided by 20. 20 is the total amount of AP students, which gives us 0.25. which gives us 25%. So 25% of heights are less than or equal to 65. Then it's asking for your height. So this answer here is going to vary, okay? And then it's going to ask you for the percentage of heights that are less than or equal than your height. So again, you're going to do the same thing as part A, but you're substituting your height. So for example, I can put my height here. Okay, so I am 5'6", so that's 66 inches. So I am 66 inches. So I need to find all the heights that are less than or equal to my height. So 66 inches, that's right here. So I'm counting all these. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 out of 20, which is going to give me 4 out of 10, 40%. So I have 0.40, which gives me 40% of people are less than or equal to my height. Okay, so again, this is going to vary based on what your height is. Okay, then it wants us to complete the table. So completing the table, one moment. Okay, so completing the table, what we're going to do is we are going to find the frequency of each of these heights. So for example, from 56 to 60. Okay, so 56 to 60. Here's 60, here's 56. There's only one height there, so I'm going to write 1. And I'm just going to go ahead and do this for the whole table before I continue with each part. 61 to 65. So 61 to 65 right here. If I count that, that's 1, 2, 3, 4. So you should have got 4. 66 to 70. So 66 right here to 70 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 71 to 75. So here's 71 to 75 is 3. And then 76 to 80 is 1. So I'm going to put a 3 and a 1. In order to find the relative frequency, that is the percentage. So I'm going to take each of these numbers and I'm going to divide by 20 because that's the number of AP students that were in our sample. So 1 divided by 20 is going to give me 5%. 4 divided by 20 is going to give me 20%. 11 divided by 20 is going to give me 55%. 3 divided by 20 is going to give me 15%. And again, 1 divided by 20 is going to give me 5%. Notice that each of these heights is all of the heights on our data plot, starting from 56 all the way to 78. Okay, so these are all the different ranges. The next column shows all the frequencies within that ranges, how many people are in those heights. The third column shows us the relative frequency. So remember, the difference between frequency and relative frequency is one is counting like numbers. So for example, our 1, 4, 11, 3, and 1. And the other one is percentages. So 5%, 20%, so on and so forth. So if we were to add all of these together, so we started at 5%, and then we have 5% plus 20%, okay, that's 25%. And then we have 25% plus 55%, which is 80%. And then we have 80% plus 15%, which is 95%. And then we have 95% to 5%, which is 100%. Okay, the reason we did this is because this is a cumulative relative frequency, meaning we should always end at 100%. So always end at 100%. And again, this is the percent, and this is the count. The counts, how many people were in those height ranges. Okay. Next, it says use the values in the table to create a cumulative relative frequency graph. So in order to do that, what we're going to do is we are going to create a first a bar graph, and that bar graph is going to include each of these ranges. So we have first 56 to 60. So 56 to 60 is 1, so it's going to be a very short right here. Then we had 61 to 65, which is 4, so it's going to be a little bit taller. And then 66 to 70 was 11. One moment, I am graphing the wrong ones. Wrong ones. Let me go back and highlight here. This is a cumulative relative frequency, meaning we are graphing this amount over here. So let me rephrase that. Go back, and I am graphing 56 to 60 at 5%. Okay. 61 to 65 at 25%. Okay, so 25. 66 to 70 at 80%. 71 to 75 at 95%. And 75 to 80 at 100%. Okay. Then it says, Miss Gaius is 66 inches tall. Estimate and interpret her cumulative relative frequency. So we are going to find 66, which is about right here. This is 66. And we can say 66 is going to be a little above this one here. Okay. So to estimate, we could say that about, let's say 35%, about 35% of students are at or below Miss Gaia's height. Okay. And then next it says estimate and interpret the height that has 60% cumulative relative frequency. Okay, so I'm going to look at 60%. And it looks like that 60% is going to be somewhere over here. So I should have made it a little bit longer right here. And I'm going to estimate that it's about 68 inches. So then we would say, approximately 68 inches, 80% of student heights. So 80% of students' heights are at or below 68 inches. Students' heights are at or below 68 inches. Notice here too, when we are looking at our graph, how we started so low. We started with the cumulative relative frequency of 5 and 25%, and then we jumped to 80, 95, and 100%. So if we look at all these points here where our bars are connecting, and we draw that line to look like that, notice right here, we have a very steep slope, okay? Go ahead and label that off to the side. This is a very steep slope. That steep slope is representing several values that are jumping, which makes sense because when we look at our data chart, we have only 4 people from 61 to 65 inches in height, and then we jump all the way to 11 people for 66 to 70 inches in height. That there's a very steep slope here, which means there is a large gap in the cumulative relative frequency between those heights. Okay, now let's look at the learning targets. Okay, so we learned 2 things today. So learning target number 1 is about percentiles. Okay. The pth percentile is the value that has p% of the data less than or equal to it, i.e., at a certain percentile. Okay. The next learning target, you guys learned about a cumulative relative frequency graph. Okay. This whole thing right here is that cumulative relative frequency is another way of saying percentile. So we did a percentile graph. And so if I have a graph here starting at 0%, then going to 25%, 50%, 75%, 100%, this is the proportion. So proportion. And on the bottom, we have our Q1, our median, and our Q3. So our Q1 is at that 25%. Our median is at that 50%. And our Q3 is at our 75%. And if we look at all of these data values, we form a different type of slope. So let's say we had data values here, 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 here. If we were to connect all these, this would talk about the slope of data. Okay. And that is all. So now you guys are working on the check your understanding in your group or on your own. And if you have any questions, feel free to ask me in class.